Hi everyone, we're continuing with lesson 20 on the standard normal distribution. So last time we talked about this key hint here, the probability that a standard normal z is less than negative 1.24 is about 0.1075. And here was a nice picture illustrating that fact. Okay, now what we're going to do is, first of all, I want to use Excel to show you why this kind of makes sense from a simulation perspective. So here, remember that this command, norm.s.inv, allows us to generate standard normal random values. Let's do a whole bunch of these. Let's do a whole bunch of these. In fact, imagine that we're doing like a million of these. What this probability statement is basically saying is that um, about 10.75% of the z-scores we're getting here will be less than negative 1.24. So about 11% of these standard normal values, these random values, will be less than negative 1.24. Okay. Part B, find the probability that as a result of this hint, the probability that z is greater than negative 1.24, what is that? What is the probability that z is greater than negative 1.24? And again, remember, it doesn't matter whether there's a bar there or not. Okay, well, we want here a right tail probability. How do we get a right tail probability? Well, what's the total area under a probability density curve? It's 1. So in order to get the complementary probability, which is what this is, to get the complementary, whether there's a bar there or not, to get the complementary probability, we subtract from 1. So the probability that z is greater than negative 1.24 is 1 minus the probability that z is less than or equal to negative 1.24, but the bar doesn't matter. So it's basically 1 minus this probability over here, the complement. 1 minus 0.1075 is 0.8925. It's a big probability. And to get that, we shade all of that there. Okay, so we want to shade all of this over here to the right. 1 minus the 0.1075, the complement. Now on software, with the table, you just have to know that you take the 0.1075 that we got here and subtract from 1. But if you use things like, let's see, well, StatTrack also gives you the cumulative. If you go to the tutorhomework.com site, all right, it does give you a right tail option. Now, I hope that you know to subtract from 1 anyway, but if you forget, well, we're putting in negative 1.24. We want the right tail probability this time, and that's the big number, 0.8925. Remember, for the left tail, it was the small number, 0.1075. For the right tail, it's going to be 0.8925. So actually, that's small for the left tail. It's big for the right tail. Remember, negative 1.24 is out here. So the right tail is a big probability. All right. And for Excel, again, it would help to know that you subtract this from 1. And Excel expects you to know that. Equals 1 minus the entry in A2. Okay. Excel expects you to know that the right tail probability is the complement, 1 minus that. So Excel expects you to be smart. Okay. Now, what about C? Find the probability that Z is greater than 1.24 based on the original picture from part A. How can we find that? Well, here's the deal. If negative 1.24 is over here, then by symmetry, wouldn't it make sense that positive 1.24 would be over here, right? Here's positive 1.24. And this bar here is symmetric to this bar over here. This region is symmetric to this shaded blue region over here. By symmetry, we get the same number. The 0.1075, which was the area over here, guess what? It's the same area over here. So the answer to C, by symmetry about the mean, the probability that Z is greater than 1.24 is the same as the probability that Z is less than negative 1.24. It's mirror images. It's mirror images. So where did I put the picture? Put up here. Okay, so these regions are mirror images of each other. The probabilities are the same. The areas are the same by symmetry. So 0.1075. Now, again, most software like Excel would expect you to just know that, but well, tutorhomework.com, again, this is the really helpful one. Right tail for positive 1.24. Click on this arrow. From the z value to the probability, we get that small probability again, 0.1075. And here the right tail picture is more consistent with what we'd expect. It's a small probability. All right. Now, in the table, you would have to go to, well, one way to do it, go to positive 1.24, you get the positive 0.8925 as your probability, subtract that from 1. Because the 0.8925 is the cumulative all the way up to there. Okay, and you want that little tail to the right. Okay. So, going on to example 2, what about an in-between probability? Software tells you that the probability that z is less than -1 is about 0.1587. You could have either Excel or websites demonstrate that for you. In fact, we can do that very quickly. Let's go over here. Let's do norm.dist -1, 0, 1, true, about 0.1587. 0.1587. If you go to tutor homework, the left tail for -1, 0.1587. If you go to the old school table, negative 1.00, well, it's right here. It's the very first entry, 0.1587. All right. In any case, that's the hint. Similarly, the probability that z is less than +1, that's a big probability, 0.8413. Okay. Now, as a result of these, find the probability that a standard normal z is between -1 and +1. Sketch a figure clearly showing this and shade in the relevant region. Think about this. Try to draw a picture, try to figure out what's going on here, and what will we do with these probabilities? We want an in-between probability. So I'll kind of give you a hint. On tutorhomework.com, it's a middle probability. If you want to check your work, let's do that. Let's take middle. Okay, so we have middle here. So left, and there should be -1 comma. Oh, there we go. Yeah, so you would enter with a comma. So for the middle probability, you would enter -1, 1, and then click on that. And the probability is 0.6827. Now, does that sound familiar? That's about 68%. Do you remember 68% from somewhere? The empirical rule. 68, 95, 99.7. Basically, this is telling us that you have about 68% within one standard deviation of the mean if you have a normal distribution in general. And this verifies that. Guess what? If you go from -2 to 2, guess what? It's about 0.95, 95%. Anyway, back to the problem at hand. Find this middle probability. All right. So again, make sure that, okay, so I'll just go all the way to here. All right. Make sure that the -1 is to the left of 0, because a lot of people make a mistake there. Make sure that the -1 is to the left of 0. 0 is this hilltop here, all right, where the hilltop is. 1 over here is to the right of the 0. We want this area, this in-between area inside here, the blue shaded region. So how do we get that? Well, we know that the area or probability to the left of -1 is 0.1587. So I'm indicating that that's basically this over here. 0.1587 is the area in white over here. Also, the probability that z is less than positive 1 is about 8413. Okay, that's the area or probability to the left of the positive one. So here I'm using arrows instead of shading because I think the arrows are a lot clearer. So we're talking about the left tail cumulative probabilities for -1, which is the 0.1587, and the left tail or cumulative probability, left tail probability for +1, which is the 0.8413. What do we do with these probabilities or areas? We subtract them to get the 0.6826 because the area I want, this blue shaded area, is going to be the area to the left of the positive one, all of this, but I want to subtract that left tail area in white, the area to the left of the 0.1587. So I just want the stuff in the middle. I feel like a 5-year-old coloring in this picture. All right. So once again, to reiterate, I'll kind of clear this thing up here. What do we want? We want the total left tail probability all the way to the left of the 1, okay? But we want to subtract off the white probability, the area to the left of the -1, and then you get the middle piece that we want, 0.6826, which is consistent with the empirical rule. Okay, so that's how you deal with in-between probabilities. All right. Working with percentiles. This is the inverse problem. Before, I gave you or we asked software to intake z-scores and give us probabilities or areas. So that's what we were doing on this tutorhomework.com site so far, going from z-scores to probabilities. But what if we go backwards? What if we go backwards from probabilities back to z-scores? This is the notion of percentiles. Okay. So let's say that in example 3, let's say that software tells you that the 85th percentile of the z-distribution, the standard normal distribution, is about 1.04. Sketch a figure clearly showing this, shade in the relevant region, and write the corresponding probability statement. Now, first of all, what does that mean? Well, let's say that you score 1.04 standard deviations above the mean on a test. It's a huge lecture hall class, 1,000 students. You scored 1.04 standard deviations above the mean. And the scores are about normally distributed. Basically, what percent of the class have you beaten? You've beaten 85% of the class. All right. Well, now, that was the kind of question we asked earlier. The percentile question is now asking this. I want to know the 85th percentile, and we're going to show it's 1.04. The question here is, if you need to beat 85% of the class to get an A on this exam, let's say the scores are curved, the grades are curved, and your professor tells you that you have to beat 85% of the students in the class to get an A. How many standard deviations above the mean? Obviously, you have to beat the mean, which is the 50th percentile, basically. The mean is the median for a normal. How many standard deviations above the mean do you need to get in order to get an A? And we're claiming that it's going to be 1.04 standard deviations, that that's the cutoff for the A. All right, well, that's what this picture basically says. In order to beat 85% of the class, okay, in order for a random test to beat 85% of the scores in the class, in order to be at the 85th percentile, then you have to score about 1.04 standard deviations above the mean. Your z-score has to be about 1.04. And this is the corresponding probability statement. The probability that a standard normal z is less than 1.04, that probability is going to be about 0.85. So I gave you the 0.85, okay, and I gave you in the hint that 1.04 was the 85th percentile of the standard normal z distribution. So the software basically tells us what this is. Here's how software can tell us. Let's go to the tables in here. Now, we know that for the 85th percentile, we know that the z-score has to be positive because the 50th percentile corresponds to z equals 0 here, right? The 50th percentile corresponds to z equals 0. We know that the 85th percentile has to be a z-score that's positive. So in the old school tables, I want to look at the positive z-scores. And this time we look inside out. Where in here do we see about 85% or 0.85? Here we have, let's use this. Okay, so I see here 0.8485 over here, 0.8508 over here, 0.85 is in the middle somewhere between these two values, and I look up. Okay, I look up to the 0.03 and 0.04. More importantly, I look to the left at the 1.0. So the z-score I'm looking for is 1.03 to 4. So between 1.03 and 1.04. It looks like 1.04 is going to do a better job. 0.8508 is much closer to 0.85 than this is. Although the interpolation is not purely linear. Meaning you can't just go by who's closer all the time. Okay, but about 1.04. Well, you can see how the table is a bit awkward. Again, it's confirming this picture over here. But let's go to, how about, well, we can go to StatTrek. StatTrek works in reverse. Okay, so 0.85 I want to put in the cumulative probability section. Press return, and I see 1.04 basically here on tutorhomework.com. Okay, so this time we want a left tail probability. Percentiles correspond to left tails. So the 85th percentile, I want to know the z-score that gets 85% over here. In fact, this picture looks pretty good. I want a probability of 0.85. We want to go from probability to z value. So I click on this arrow down here. It's about 1.04. Okay. On Excel, what is the 85th percentile of the z distribution? In other words, find the z-score, z star, such that the probability that a random standard normal z is less than that z star score is about 0.85, equals norm.inv, it's the inverse problem. Given a probability, find the z-score. Given the left tail or cumulative probability, find the z-score. So 0.85, comma, we want a standard normal. Okay, wow, to many decimal places, it rounds off to about 1.04. All right. So tutorhomework.com kind of puts it in a nutshell. I can either go from a z value to a probability. So 1.04 gets us a probability of 0.85, or I can feed it a probability and I get the z-score, which inverts the previous problem. All right, so we've really talked a lot about the standard normal distribution. In the next lesson, we're going to talk about all normal distributions, and this is the key. The standard normal distribution is the key to all normal distributions in yards, feet, miles, light years, whatever. Until next time.